In any triangle, the sum of all the angles is equal to 180 degree. So 1 radian is nothing but an angle subtended at the circle by a unit radius whose radius is equal to an arc length. So when you are converting any degree to radian, you always multiply pi by 180. So in this entire process, we will be learning the conversion of radian to degree and degree to radian. Hello everyone, a warm welcome to one and all. This is Yashruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Today in this session, we are going to take up the new chapter, Angles and Trigonometric Ratios. So we have studied basically the angles in degree measure. So here in this session, we are going to study the angles in radian measure and their conversions from degree to radians, radians to degree. So let us see the weightage of the chapter for this year. Here in this chapter, you will be getting 2 marks MCQ, 2 questions on short answer for 4 marks, overall 4 questions of 6 mark questions. Now here, let us see what do you mean by a radian measure. So radian measure means a unit or an angle which is subtended at the center of the circle by an arc whose length is equal to the radius of the circle. Now consider a circle here and this is the radius of the circle. An arc of length here which is equal to the length of the radius and the angle subtended by this which is also represented as theta. This is called as 1 radian. So 1 radian is nothing but an angle subtended at the circle by a unit radius whose radius is equal to an arc length. Now if I say 1 radian, then 1 radian is nothing but the angle subtended in the circle with 1 unit of radius whose arc length is also equal to 1 unit. So therefore, if the distance of the arc length and the arc length is usually denoted by L and radius by R. If L is equal to R and the sector which contains the angle, that is the minor sector, so that represents the radian. Now here, when we are converting the radian to degree or degree to radian, so we have one common factor to be multiplied. So let us see what is the conversion when you are converting the radians to degree measure. So 1 radian generally or approximately is equal to 57 degree, 17 minutes and 45 seconds. So why are representing in minutes and seconds? Because we always consider a clock as a unit circle here. So if you want to find out 1 radian, so it is always assumed that 1 minute is nothing but 60 seconds and 1 degree is nothing but 60 minutes. So if the lag hand in the clock has to move to 1 degree, then it has to cover 1 complete circle and 1 complete circle is nothing but 60 minutes. So that is represented as 1 degree. So therefore always 1 degree is nothing but 60 minutes and 1 minute is nothing but 60 seconds. So basically we always express all angles in terms of pi radians. So here pi radians is nothing but 180 degree. So the semicircle, the angle of a semicircle which is 180 degree, so which is a straight line, so that 180 degree is always considered as pi radian and all other remaining angles are expressed in terms of multiples of pi. So here 2 pi is nothing but 360 degree. So 1 complete angle which is nothing but 360 degree is nothing but 2 pi radians, and if you want 90 degree we can write it as pi by 2. If you want 45, it is pi by 4. So pi by 2 is 90 degree, pi by 4 is 45 degree. So like this, so this is the same angle which is written in terms of radians and this is in degrees. So some of the standard angles to remember is, so first is pi. So pi is nothing but 180 degree. Next is pi by 2, which is 90 degree. So pi radians, not the value of pi. Pi radians is nothing but 180 degree. So pi by 2 radians is 90 degree. Next we can go for pi by 3, which is 60 degree. Pi by 4, which is 45 degree. Pi by 6, which is 30 degree. And 0 is always 0 radians. 0 degree is nothing but 0 radians. Similarly, we can also take 2 pi. which is nothing but 360 degree. Some of the other angles which we can write, we can either take this as a sum or difference or multiples of these standard angles. So all these are called as standard angles. Now let me take an example of 20 degree. So what is 20 degree in terms of radians? So when you are converting any degree to radian, you always multiply pi by 180, the factor pi by 180, so that you can convert any degree angle into radian measure. Now if you are multiplying this, so here we can clearly say pi by 9 radians is the value of 20 degree in terms of radians. Now consider 2 pi by 3 radians. So what is the value of 2 pi by 3 radians in degrees? So when you are converting the radian measure to degree, you always multiply a factor 180 by pi to the given radian measure. So now if you multiply here, it get cancels. So 2 into 60, which is equal to 120 degree. So 120 degree is nothing but 2 pi by 3 radians. So always remember these standard functions or the standard angles. That is 0 radians is nothing but 0 degree. 30 degree is pi by 6, 45 degree is pi by 4, 60 degree pi by 3, 90 pi by 2, 180 pi, 360, 2 pi in terms of radians. So in this entire process, we will be learning the conversion of radian to degree and degree to radian. So once again, if you are converting degree to radians, multiply a factor pi by 180. If you are multiplying radian to degree, multiply a factor 180 by pi so that you can convert it into degrees. Now let us take problems. Express the following in radian measure. The very first one is 25 degree. We need to convert this into radians. So what factor we should multiply? Pi by 180. So if we cancel this, 5 5s are, 5 3s are, 5 6 are. So we will get the value as 5 pi by 36. And if you put 180 here, again you will get back the same result, 25 degree. Next question, 210 degree. So 210 degree into pi by 180. So here 3 6 are 18, 3 7s are, 10 6 are, 10 7s are. So the value is 7 pi by 6. So remember pi by 6 is nothing but 30 degree. So 3 7s are 21, so 210 degree. So we can also multiply the standard angles to get certain angles here, or we can use the factor pi by 180 to multiply with the given radian measure, or we can multiply pi by 180 to the given degree measure to convert it into radian measure. Next one we have 36 degree. So pi by 180 into 36 degree. So we can clearly see here 10s are, 2s are, 2 1s are, 2 5s are. So we have pi by 5 radians. The small letter c with index indicates the radians. Next one, express the following in sexagesimal measure, which is nothing but degrees. So here we have 7 pi by 3 radians. So here we can take two methods here. Pi by 3 is nothing but 60 degree. So 7 into 60 degree, which is 420 degree. So that means we can convert pi by 3 into degrees and then multiply 7 so that we can easily get 420 degree. Or to any radian measure, if you multiply 180 by pi, then also we'll get the same value. So pi get cancelled. 3 1s are, 3 60s are, 6 7s are 42, which is equal to 420 degree. If you know the standard angle values very well, it is easy to simplify, or else use the factor 180 by pi to multiply with the given radian measure. Next one, 3 pi by 5. So 3 pi by 5 into 180 by 5. Pi get cancelled. 5 1s are, 5 3s are 15. Again 5 6 are 30. 36 into 3. 108 degree. Next one, pi by 24. So the value of pi by 24 multiplied with 180 degree by pi. Pi cancels. 6 4s are 24, 6 3s are 18, 0. So which is equal to 30 by 4 degree, which is equal to 15 by 2, which is 7.5 degree. Next question. The angles of a triangle are in the ratio 3:4:5. Find them in radians and in degrees. So we know that in any triangle, the sum of all the angles is equal to 180 degree. Since the ratio, common ratio between them is 3:4:5, let's take the common angle as x. Then we have 3x plus 4x plus 5x is equal to 180 degree. So here we will get 12x is equal to 180 degree. So x is equal to 15 degree. So therefore the angles are 3x, which is 15 into 3, 45 degree, 4x, which is 60 degree, and 5x, which is equal to 75 degree. Now we have found the angles in degrees. Let us convert this into radians. So we know here x is 45. So 45 into pi by 180. So cancels. We'll get the value as pi by 4 radians. Similarly, 60 into pi by 180. So cancels. We will get pi by 3 radians. And 75 into pi by 180 degree. So which is equal to 5 pi by 12. Cancelling with 5. So now here we know the standard angle 45 degree as pi by 4. We can also write directly. If you learn the standard angle 60, here also you can directly write pi by 3. Whereas 75 you can use the formula. Next question. The difference of two angles is 45 and their sum is 90 degree. Find the angles in degrees and radian. So let me take the two angles as A and B. So given A minus B is equal to 45 degree and A plus B is equal to 90 degree. So adding these two, I'll get 2A is equal to 135 degree. So A is equal to 67.5 degree. So now if I substitute A in any one of the equation, so 67.5 degree plus B is equal to 90 degree, then B is equal to 22.5 degree. Now we have A and B in degrees. To convert A in radians, we have 67.5 into pi by 180 degree equals 67.5 can be written as 67 1 by 2 into pi by 180. So which is equal to 135 by 2 into pi by 180. So cancelling this will get 3 pi by 8 in radians. Similarly, if we convert 22.5 in degrees, this is 22 1 by 2 into pi by 180 degree, which is equal to 45 by 2 into pi by 180 degree. So cancelling this, we'll get the value as pi by 8 radians. So therefore, the two angles are 67 degree and 22.5 degree in degrees and 3 pi by 8 radians and pi by 8 radians in radians. Next one. The angles of a triangle are in AP, the least being 36 degree. Find the angles in degrees and radians. They have given that angles of a triangle are in AP. So let me consider the angles as A minus X, A plus X. Now since these are angles in a triangle, the sum of these three will be equal to 180 degree. So here 3A is equal to 180 degree, A is equal to 60 degree. So since A is equal to 60 degree, the least angle is 36. So that is, what is the least angle between them? A minus X is equal to 36 degree. So therefore 60 degree minus X is equal to 36 degree. X is equal to 96 degree. So the value of X is 96 degree. So this implies X is equal to 24 degree. So now we have A, we have X. So therefore A minus X is equal to 60 minus 24, which is 36 degree, already given. A is equal to 60 degree. A plus x, which is equal to 60 plus 24, which is equal to 84 degree. So therefore, the angles of a triangle are 36 degree, 60 degree and 84 degree. So now we need to convert them into radians. So therefore, it is 360 into pi by 180. We know the standard angle 60, which can be written as pi by 3. This is again 84 into pi divided by 180 degree. So this is, we cancel, we will get pi by 5, pi by 3. Again, this if we cancel, we will get 7 pi by 15. So these are the angles in radians as well as degrees. Next question. The angles of a triangle are in AP and the greatest is 5 times the least. Find the angles in radians. So first let us calculate the angles of a triangle are in AP. Let me consider this as the same thing. A minus x plus A plus A plus x is equal to 180 degree. So we will get again 3A is equal to 180 degree. A is equal to 60 degree. Also they have given the greatest. So the greatest is nothing but A plus x. So it is 5 times the least. A minus x. So solving this, we get A plus x is equal to 5A minus 5x. So here we will get 4A is equal to 6x, or x is equal to 4A divided by 6, which is equal to 2A by 3. Now value of A is 60. So 2 into 60 divided by 3. 3 ones are, 3 twos are. So it is equal to 40 degree. Now the x value is 40 degree. So therefore the angles are A minus x. That is 60 minus 40, 20. A, which is 60. A plus x, which is 60 plus 40, 100. Now 20 degree. So 20 degree into pi by 180. So we will get the value as pi by 9. 60 degree can be written as pi by 3. So remember pi by 9 is 20 degree. So if we multiply 5 here, then it will become 100. So we can write it as 5 pi by 9. Pi by 9 is 20. 20 into 5 is 100. So therefore the angles in the radians are pi by 9, pi by 3, 5 pi by 9. Next one. The angles of a quadrilateral are in AP and the greatest of which, the double the least, express the angles in degrees and in radians. So we know that in any quadrilateral, we have the sum of them is equal to 360. Now they have given, they are in AP. So therefore let me consider the angles as A minus 3x, A minus x, A plus x, A plus 3x. Also they have given the greatest is double the least. So using the sum of quadrilateral, A minus 3x plus A minus x plus A plus x plus A plus 3x, this is equal to 360. So x quantities get cancels. 4A is equal to 360 degree. So we get A is equal to 90 degree. Now the value of A is 90. Again using the equation, A plus 3x is twice A minus 3x, which is equal to 2A minus 6x. Now here, solving this, we will get 9x is equal to A. So value of A is equal to 90 degree. Therefore, x is equal to 10 degree. So now the angles are A minus 3x. So that is 90 minus 3 into 10, 30, comma 90 minus 10, comma 90 plus 10 and 90 plus 30. So this is equal to 60 degree, 80 degree, 100 and 120 degree. So here we know that from the last problem, pi by 9 is equal to 20 degree. Since all these are multiples of 20, we can express them as a multiple of 20. So 60 degree is already we know, that is equal to pi by 3. 80 degree is 4 into 2s are 4 2s are. So I can write it as 4 pi by 9. 100 can be written as 5 pi by 9. 120 can be written as 6 pi by 9. So pi by 3, comma 4 pi by 9, comma 5 pi by 9, and we cancel this, we'll get 2 pi by 3. So that should be the reduced form. So therefore, angles in radians are pi by 3, 4 pi by 9, 5 pi by 9 and 2 pi by 3. So thus in today's session, we have learned another form of expressing the units of angles. So that is in radian measure. Also we have learned the conversions of radians to degrees and degrees to radians. I'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.